Hypersonic missiles have emerged as game changers in modern warfare, revolutionizing the dynamics of military strategy and defense. With speeds exceeding Mach 5, these missiles offer unmatched agility, range, and unpredictability, posing significant challenges to traditional defense systems. These ammunition has undeniably become the most talked about ammunition of the century and have raised questions like, how fast and powerful are these missiles? Join us as we take you through the features of the world's fastest hypersonic missiles as revealed by the United States. The development of hypersonic missiles is a solid proof of the evolution of warfare strategy. From the very first ammunition that was developed by China to weapons and invisible aircraft that can fly at several speeds faster than that of light. We would be checking out the capabilities of the world's most powerful missiles and what country they were developed in. The very first on the list is the renowned Kov-47-2 Kinzhal. It is a Russian missile that is launched from the air and travels at hypersonic speeds. It is estimated to reach distances of 460 to 480 kilometers and can fly as fast as Mach 10. The missile can carry either regular or nuclear warheads and can be launched from two 22M3 bombers, MiG-31K interceptors, or even the upgraded and modified version of the Su-34 fighter bomber. It is the first missile on the list for a reason, and it is important to note that it is the very first hypersonic weapon ever used. This hypersonic missile became fully operational in December 2017 and is part of Russia's new strategic weapon that was presented by President Vladimir Putin in March 2018. It is said to be stationed at air bases in the country's Southern Military District and Western Military District. The design of the Kinzhal missile is quite similar to that of an older ground-launched 9K-720 Iskander missile. But the major difference between these two is that the Kinzhal is modified for air launching. It's said to have the ability to hit both stationary targets and moving ones like aircraft carriers. Because of its hypersonic speed, it can penetrate targets faster and better than slower cruise missiles. Each Kinzhal missile is said to cost a whopping amount of $10 million. The next on the list is the Fateh-2 hypersonic missile. This missile was unveiled by Iran during a visit by Supreme Leader Ayatollah Ali Khamenei to the Islamic Revolutionary Guard Corps Aerospace Force Museum in Tehran on the 19th of November 2023. The Iranian media coverage of the event showed that the missile consists of a ballistic missile motor that bears a striking similar to the one used to power the Fateh-1 missile, and a re-entry vehicle that looks like it was inspired by Boeing's X-51 Wave Rider experimental hypersonic cruise missile, albeit without an air intake for a scramjet engine. The media also reported that the Fateh-2 has a range of 932 miles, not much farther than the 870 miles of the Fateh-1, which has a re-entry vehicle powered by a solid fuel rocket motor with a movable nozzle that allows it to change course when outside the atmosphere to accurately evade air defense systems. The next hypersonic missile we would be looking into is the HAWC, also known as the Hypersonic Air-Breathing Weapon Concept. It is a scramjet-powered hypersonic air-launched cruise missile project at the U.S. Defense Advanced Research Projects Agency that had a successful hypersonic flight announced on September 2021. The scramjet propelled the missile at a speed that is greater than Mach 5. On January 30, 2023, the final successful flight test of the HAWC was reported by DARPA and Lockheed Martin. The missile was able to fly at a speed of Mach 5 at an altitude of over 60,000 feet for more than 350 miles, which demonstrated its improved performance and capabilities. Other technology developed for the HAWC demonstrator was used to influence the design of the Hypersonic Attack Cruise Missile, a U.S. Air Force program of record to create a scramjet-powered hypersonic missile. The contract to develop HCM further was awarded to Raytheon in September 2022. The HSTDV, or Hypersonic Technology Demonstrator Vehicle. This hypersonic missile is an unmanned scramjet demonstration aircraft for hypersonic flight. It is being developed as a carrier vehicle for hypersonic and long-range cruise missiles, and will have multiple civilian applications, including the launching of small satellites at low cost. The HSTDV program is being run by the Defense Research and Development Organization. The design for connecting the airframe with the engine was completed 2004. In May 2008, Dr. Saraswat mentioned that they were working on the HSTDV project in order to demonstrate a scramjet engine's performance at altitudes of 15 kilometers to 20 kilometers. This technology can be used for various civilian purposes, like launching satellites affordably and developing long-range cruise missiles. Israel and Cranfield University from the UK have also helped with the wind tunnel testing for the HSTDV program. Another unnamed country is also assisting. Russia has provided crucial aid, as reported. India's main partner in defense industry is Russia, which has significant experience in hypersonic propulsion research. The air vehicle being built is about 1 metric ton and 5.6 meters long. It has a flattened octagonal shape with stub wings and tail fins, along with a 3.7-meter air intake. The scramjet engine is placed under the mid-body, and the rear part serves as an exhaust nozzle. Also, the vehicle's bottom, wings, and tail surfaces are made of titanium alloy, while the top surface is developed with aluminum alloy. The inner layer of the double-wall engine is made of niobium alloy, and the outer layer is made of nimonic alloy. When the material used in the scramjet engine development was denied due to technology restrictions, a new program was developed to begin the materials in-house. This made India self-reliant in this area, and the ground tests for the scramjet engine were successful for 20 seconds instead of the initial 3 seconds. About $30 million was spent on the design and development of this missile, with an additional $4.5 million for the HSTDV prototype development. Next, we have the 14X. This technology is a technological demonstrator of a hypersonic air-breathing propulsion system based on supersonic combustion or scramjet to be tested in the Earth's atmosphere at a speed of Mach 7 or 5,328 meters per hour. On the 14th of December 2021, the very first qualification test flight of the 14X was conducted from the Alcantara Space Center. Brazil has been studying aspirated hypersonics since the 1990s, but they only started planning for it in 2007 with the PropHyper project. This project was officially launched by the Air Force in 2008 when Tiago Cavalcanti Rolim, an engineer captain of the Brazilian Air Force, began his master's degree at the Instituto Tecnológico de Aeronáutica. His thesis was focused on the waverider configuration. The project began developing an experimental model with the Institute for Advanced Studies in the same year. Testing of the hypersonic engine began in October 2009. India's BrahMos 2, also known as BrahMos Mark II, is a super-fast missile being developed jointly by India's Defense Research and Development Organization and Russia's NPO Mashinostroyenia. They've come together to form BrahMos Aerospace Private Limited. This missile is expected to travel up to 1,500 kilometers at a speed of Mach 8. It's powered by a scramjet air-breathing engine during its flight. More details about its cost and size haven't been released yet. It is the second variant in its series of cruise missiles and is expected to have a range of 930 miles and a speed of Mach 8 during the cruise stage of the flight. The missile will be propelled by a scramjet air-breathing engine. Initially, the BrahMos 2 missile was planned to only reach a distance of 290 kilometers because of a rule called the Missile Technology Control Regime, which Russia agreed to. This rule restricted countries like Russia from helping others make missiles that can go over 300 kilometers. But after India joined the MTCR in 2014, the BrahMos 2's abilities were significantly improved. It's supposed to be twice as fast as the current BrahMos Y and has been called the fastest cruise missile worldwide. The testing process was supposed to start in 2020, but unfortunately it got delayed. However, It is likely that the new Russian naval destroyers will also have BrahMos 2 missiles. The missile was named to honor India's former president, APJ Abdul Kalam. According to the CEO of the BrahMos program, the future BrahMos 2 will be similar to the 3 M22 Zircon. A report from April 1, 2023 said that India asked Russia to share the technology of the Russian 3 M22 Zircon missile, which BrahMos 2K will be based on. Russia agreed, but they haven't done it yet because of issues like their relationship with China and because giving India this technology would make them more powerful at sea. Next on the list is the FCASW, also known as the Future Cruise Anti-Ship Weapon, or Spear-5, is a new missile program that was started by France and the United Kingdom in 2017. It aims to replace their older anti-ship missiles like Storm Shadow Scalp, Exocet, and Harpoon. Both countries are equally funding this project, led by the European missile maker MBDA, as part of their close defense relationship under the Lancaster House treaties. Italy joined the program in 2023. In February 2022, agreements were signed to start preparing for FCASW. As of 2022, the program was considering developing 2 types of missiles, one that flies low and hard to detect, and another that flies fast and can maneuver well. They decided not to pursue a hypertonic solution, like CVS-401 Perseus, an early concept. The program plans to finish assessing the technology by 2022 and start manufacturing from 2025 to 2035. They also announced 2 versions, one for deep strike land attacks by 2028 and another for anti-ship purposes by 2035. Another powerful missile is the YJ-21, also known as Eagle Strike 21. It was majorly designed to attack ships and is said to be able to hit both land targets and surface ships with a fast and maneuverable warhead. This missile's design might be based on another Chinese missile called the CM-401, but with more advanced features. According to the Chinese Navy publications, the missile flies at a hypersonic speed of Mach 6 and reaches Mach 10 when it's about to hit its target. This technological marvel unveiled it before their 7th anniversary, launching it from a Type 55 destroyer's vertical launch system. There's also an export version called the YJ-21E, which was shown at Airshow China 2022. The 9th on the list is the DF-ZF, which is a Chinese hypersonic glide vehicle. It was previously named as the WU-14 by the Pentagon and became fully operational on October 1, 2019. It is designed to be deployed by the DF-17 medium-range ballistic missile specifically designed to carry the DF-ZF. The glider is said to reach maximum speed between Mach 5 and Mach 10. Its capability is not limited to delivering nuclear weapons alone because it can also be used to perform precision strike conventional missions. These hypersonic glide vehicles are harder to stop than regular re-entry vehicles used in missile because the RV follow a predictable path through the atmosphere. But HGVs, like the DF-ZF, can change direction after re-entering, making them harder to detect, target, or stop if an initial attack fails. Gliding also lets them travel farther and makes them more maneuverable. Although this gliding feature creates more drag, it still flies far and low, making it hard for some anti-missile systems to intercept. However, it becomes easier for lower-tier interceptors to target them. The DF-ZF could be put on different Chinese missiles, like the DF-21 and DF-31, giving them longer ranges. It might first be used for shorter-range purposes, like attacking ships, before being used for longer-range attacks. The United States might focus on developing directed energy weapons to counter these fast-moving targets, but these weapons are still experimental. Even though HGVs are hard to stop during mid-flight, they face challenges in the final phase of their journey. They can only maneuver a lot during mid-flight because of intense pressure during the final phase. Most defense systems are better at stopping missiles in the final phase, and when HGVs re-enter the atmosphere at high speeds, they create a plasma sheet that disrupts communication and sensors. This means they might have to slow down or rely on less accurate navigation systems, making it harder for them to target moving objects like aircraft carriers. That's why the DF-ZF is mainly used for land attacks for now, although there's work on making a version that can target ships. Also, the Hypersonic Technology Vehicle 2 is an experimental aircraft that can fly incredibly fast, up to around Mach 20. It's part of the DARPA Falcon project and is meant to test out technology. The goal is to give the United States the ability to hit any target worldwide within just 1 hour using an unmanned aircraft that flies at hypersonic speeds. This project requires the collaborative effort of the Defense Advanced Research Projects Agency and the United States Air Force. The first part of the project aims to develop a small launch system capable of accelerating hypersonic gliding weapons, as well as launching small satellites into Earth orbit. The second part aims to develop hypersonic weapon systems. The process of designing this hypersonic vehicle encountered several technical issues like the creation of protection structures that are strong yet lightweight, making the airframe aerodynamic with a high lift-to-drag ratio and developing automatic navigation control systems. Different departments, like aerothermodynamics and materials science, collaborated in the creation of this vehicle and worked on various aspects, including navigation, guidance, and control systems. The vehicle could travel long distances very quickly, covering the distance between London and Sydney in just 49 minutes. The HTV-2, that was designed by Lockheed Martin, was made with carbon composite material to withstand extreme temperatures that the aircraft encounters during its flight, which can reach over 1,930 degrees Celsius. These materials' durability is important in protecting the internal components that are located just inches from the surface, since steel melts at lower temperatures. The last, but not the least missile is the Hwasong-8. It is a North Korean missile claimed to be mounting a hypersonic glide vehicle. It was first tested on September 14, 2021, with 4 missile launches. According to KCNA, the DPRK's official press agency, the hypersonic glide vehicle separated from its booster after traveling 373 miles on its January 11th flight. Subsequently, it flew a gliding trajectory during which it made a turn before hitting its target at roughly 621 miles from the launch site. The missile significantly increases the threat that North Korea can put on South Korea because the hypersonic speed allows the missile to reach its target in a shorter duration, and also the additional maneuverability gives the ammunition a better chance at defeating other missile defenses. Also, the Japanese tracking data from a test launch suggests that the Hwasong-8 is truly a hypersonic ballistic missile, as described by North Korea. The idea of launching a hypersonic missile was first mentioned during the 8th Congress of the Workers' Party of Korea as part of the 5-year plan for defense science development. Kim Jong-un also mentioned other weapons like solid-fuel intercontinental ballistic missiles during that time. While North Korea already possesses hypersonic missiles like the KN-23 and KN-24, gliding vehicles are thought to be better at getting past missile defenses. The knowledge gained from working on these short-range missiles likely helped in developing this new missile. The missile is said to be based on either a shortened Hwasong-14 first stage or a Hwasong-12. The gap between the verniers and the main chamber suggests it's likely the Hwasong-12 because of the slightly longer gap. Compared to the original Hwasong-14, the fuel tanks of the main stage would have been shortened by about a quarter. The hypersonic vehicle is placed on top of the missile and has a typical shape like other such vehicles, such as the DF-ZF, with fins for controlling it in flight. However, without data on the missile's trajectory, It's hard to know how the re-entry vehicle will travel. The missile probably didn't fly over Japan in a flat path, and a lofted path wouldn't be suitable for testing such vehicles. Nevertheless, the missile is still a significant demonstration of missile technology. It marked the 6th consecutive successful flight of the Pektusan rocket motor, which is also used by other missiles. It also showed other technologies like fuel amplification, where fuel can be loaded into the missile months or years before launch, reducing launch preparation time. According to the Joint Chiefs of Staff, the missile could potentially be intercepted if it flies at Mach 3. However, if it reaches hypersonic speeds, it could reach southern regions of South Korea in around a minute, much faster than a Scud missile. The missile displayed at the Defense Exhibition in October 2021 had some differences compared to the version launched in September. The warhead was likely mounted on a Hwasong-12, and the missile was seen mounted on a MAZ 547, which is longer than the one tested in September. It's unclear if the same rocket used for the Hwasong-8 launch would be used for future launches or different payloads. The launch of the missile also served a political purpose, showing the government's ability to bolster its deterrence. It garnered international attention, joining a race among major military powers to deploy advanced weapon systems and potentially changing the military equation in East Asia. However, while the missile improves chances of warhead survival, it's unlikely to form a significant part of North Korea's missile force due to its high cost. This launch also appears to be part of a growing arms race in Korea, demonstrating technological prowess over South Korea. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there!